Good afternoon, everyone. I'm Chou from the Central University. It's my pleasure to welcome you to the fifth session of our GIS online course series. So today we are delighted to have with us Professor Huang from the Department of Civil Engineering and the National Kaohsiung University of Science and Technology. So Professor Huang is a distinguished expert in geotechnical engineering, soil liquefaction, and earthquake engineering. So today he will bring his deep knowledge in slope stability, sediment disaster, and innovative disaster monitoring techniques. He is also well versed in applying 3D printing technology in these areas. So today he will present an insightful lecture on disaster management using the GIS and the remote sensing. So let's extend a warm welcome to Professor Huang. Professor Huang, please. Thank you.
Okay, thank you, Dr. Xu, and good afternoon, everyone. I'm Dr. Huang, and for those coming from the different time zones, good morning or even good evening. Today, I'm going to share with you a short course regarding the GIS and remote sensing application. Today's presentation will focus on how we apply those techniques in our real actual natural disaster monitoring. So before we start it, I need to share my screen with every one of you. So hold on a second. Okay, so let's start our today's presentation. The title is Disaster Management using the GIS and the remote sensing. The focus will be on the disaster management. Okay, let me introduce myself. I'm Dr. Huang. I currently work as an assistant professor at the Department of Civil Engineering of the National Kaohsiung University of Science and Technology in Taiwan. And I earned my PhD degree from the United States and specialized on the geotechnical engineering. And today is my great honor to share my experience and my some kind of working results with every one of you regarding the disaster management. So outline today, we will start from the monitoring basis. There are some basic concepts, considerations, and also some restrictions when we face the issues of monitoring natural disaster. And I will provide you several newly developed technology like the WSM or IoT. And to be specific, I will use some cases. So we will focus on the three major natural disasters in Taiwan. And from them, we will also learn something from the experience in our monitoring system. The first one, we will talk about the landslides. And the next one is the debris flow. And the final one, we're talking about urban floods, especially for the flash floods today. So before we start it, I think every one of you is afraid of something in your life. But for the Mother Nature, how about the volcanoes? This is a natural disaster. How about the wildfires, earthquakes, or the landslide, large-scale landslide, and the flooding? In addition to those of them, the tornadoes sometimes has a disaster in certain areas, and even we have avalanche in the remote area. So all these disasters, I would say all these natural hazards, it comes from our Mother Nature. When we talk about disaster, meaning there's something happened to us, to the people living around the area, to the property around the area, or even there's a damage caused by the natural hazards. So we call it disaster. That will be our topic today. So the first thing we will look at, what is the monitoring basis? Well, when we're talking about monitoring basis, I just highlighted and emphasized on only three simple questions. Why do we need to do the monitoring? What object you want to monitor, and how we monitor the object or the disaster you want to know. Is there anyone can hear me? If you
Yeah.
have any questions, okay,
Yes,
okay,
no problem.
okay. Because I see someone leave the message about you cannot hear the sound. Okay, that's fine. So let's move on. So the monitoring, the number one question, why? Why we want? Good. Thank you for your response. So why we need to monitor? Because we want the people to be aware of the awareness, to be aware of the threats from our natural hazards. So remember, when we talk about disaster, we focus on the disaster that related to the human casualty or even the property damage. So that is our next questions. What kind of disaster you want to monitor? So we need to think about it. If you want to monitor, for example, earthquakes, we need to know the causes of the earthquake. Why the earthquake occur at the location A, not at the location B? So there's a difference environmentally. So we need to find out the causes of the hazards. Then we need to think about what is the major concerns about the people. For the area that is far away from here, maybe there's no one living there, earthquake is just a natural behavior from our mother nature. We don't need to worry about that. But if earthquake occur at an urban area, that will be a serious issue. So we need to consider what kind of subject, what kind of a disaster, and also the causes we want to face and we want to monitor. And then the final question is how we monitor the disasters. So the major reason we want to know the disaster is because we usually need to make a decision, especially for the people living at a dangerous area, and especially for those governments that can handle the safety of the people. So we want to make a decision, then we need to collect useful information from the site. So we want to collect the data, maybe for the academic research, and maybe to set up warning systems, and maybe we can provide us an insight of the prediction. All those activities will help us understand better about the disaster and also can help us to make a decision what's going on for the next step. So this is the three major questions about the monitoring basis. These are simple questions, so you need to ask ourselves why we need to monitor the disaster, what kind of the what kind of subject we need to take care about the monitor, and how we do the monitoring jobs. So the first one, we want to know to collect the data. That's why we need have a lot of sensors and instruments installed on the site. This is the major purpose. The next one, when we try to collect the data, we will face one important question, the communication. We want to send the data from the site to wherever you collect your data. We can send that back to our emergency operations center or back to another computer center, for example. But in between, we need to rely on a stable communications. So you can use the network, 4G or 5G, your cell phone network. That is most convenient one on hand. Or we can consider different network like WSN or Internet of Things. We will discuss later in the presentation. So we want to receive and send the information from the site to some destination, we can make a decision. So when the people obtain the information from the site, and when we are worried about a certain type of the disasters, then we need a system to process all the information into a kind of ratings or labels, or even we can send out the warning message to the person who made decisions. And then we can evacuate the people if their life has the threats from the natural disaster. So these three steps, the sensors, the reliable communications, and the response is importantly regarded with the monitoring system. So before we answer 3 simple questions, then the next step, we need to consider how we set up our monitoring system. So when we talk about the technology used today for monitoring, today we will highlight the GIS. So GIS, well, in short sentence, I just quote from the Mike Derricott. GIS is a powerful and essential tools because when we utilize in the GIS, we can providing providing useful information. We can take a critical advantage when we try to protect, preserve, conserve, and even to restore the environment. Here, I would like to highlight that we can protect. You can protect people. You can protect your environment, or you can avoid further damage from the natural disaster. GIS can collect all of this information on one single platform, and after proper processing, you can get the useful information and you can do something else for the next step. So what's the roles of the GIS? Of course, the first one is data processing. GIS can provide you a platform to point out the locations, especially the location of the disaster in 3D view. So this will give you an idea about how close all this location is, or how wide the impact of the disaster could be. You can put them on the GIS platform and you can visualize them. And whenever we see something, your brain will start to work. When we see something, we will consider what that means. And then we need an analysis tool. And GIS is a very powerful tool that can convert complex information into a map. So this the map form result is quite critical for decision making. When people see a map, there's a lot of information on that. We can highlight the important ones, and also we can pull out the suggestion for our decision makers. Then it will move on to the management system. So when we see something, we know something, and we detect something occurring, then you need to make decision for the next step. So this is the GIS platform that could help people understand not only the disaster, the location of the disaster, but also can help them to consider what to do to protect our people or to remediate the impact of the disaster. So this is quite a useful tool for the GIS. So, well, probably most of you can understand, GIS can help you to doing the disaster management, can identifying the hazards, and monitoring the disaster damage. I highlight these 3 useful, mostly commonly used subject for the GIS application. And I want to emphasize that GIS is helpful and useful because it can put all this information into a map. So you can create a 3D map or even just 2D map. It will be clear and easy to read for anyone who is interested about the disaster management and protection. So this is very useful. I think it is the basis and the important role of the GIS in our disaster management. So let's move on to the remote sensing. Well, that is a different application or technology different to the GIS. Remote sensing, we focusing on the skill or the tool you use to obtain wide range information, either from the aircraft or from the satellites. Because he can obtain the information on the ground surface by different sensors, and the data is, I would say, the data is a lot of information within one image. So remote sensing can help us to understand the change with time of certain locations. We can even watch the global Earth for the wider range with the time. So you can even using the remote sensing to watch or monitor a smaller area, for example, on the campus or your cities. Then we can watch the difference with the time by the remote sensing. So this is a very good tool to obtain information in a rapid manner. In other words, you can probably get the information of the Earth every hour for the same locations, or even faster every half hours whenever you have the satellite images. So that is the remote sensing we use today. So why we need to use in the remote sensing, why we not just use the, well, I would say the UAV photos, because we have a larger area to monitor. So when you have the issue that you want to monitor a wider range, well, a larger area, and for a longer time, then you can consider using the remote sensing, just apply the satellite schedule. And then whenever the schedule of the satellite can fit you, and then he will provide you the images on your request. So first one is we want to monitor the larger area. The next one is, I would say, how often you want to obtain a new data. Remember, in the previous slides, we talked about the monitoring. We need to put the sensors on site. That is a small scale monitoring. But if we want to know what's going on around the area of interest, then you can consider using the remote sensing. And the next question is how often you want to monitor the change. So the satellite today, we have hundreds of the satellite orbiting the Earth every day, every hour, I would say every minute. So you can obtain high resolution image of the ground surface depending on the schedule you want. So that is a very good tool and the source of the information to help us understand what's happened around our area. The next one is because it's easier to obtain information. It's a non-intrusive and a systematic collection because for a given satellite, you will orbit the Earth on the same track every day. So you can compare the images of the different time, and you can try to find out the change on the ground surface. Maybe you can identify the potential threats coming from the natural disaster. And he will help us, our decision maker, to make decisions. Well, let's take an example. Whenever you have the flooding, if you are the governor of your living city, you want to know what's going on in the past 3 hours, and you need to predict what would be in the next 1 hour. And then you can ask someone to help you to obtain the wide range satellite image for the past 3 hours. And then you can see the propagation of the flooding. Now, and you can make your decision. The people living at a threatening area, they need to evacuate maybe in next half hour. And then you can announce the early warning for your people to protect their lives and their property. I think this is an easier way of using the satellite image to help you make a prompt decision whenever you face the disaster. So based on in a short summary, the remote sensing can do a lot of things. I want to highlight the two important applications in today's presentation. Number one is identifying the location of disaster. Well, location is quite important. That it fits the benefits of using GIS, because GIS also provides you the location of our space. So location is the number one issue and the number one important information for disaster management. The next one, you can determine the extent of the damage. Sometimes when you try to obtain the impact zone from the on-site sensors, that is not good enough or is not sufficient for you to determine how large could be of the damage. But if you use the remote sensing, it will provide you a wider, even larger area. You can have an overview of the area way beyond your interest area, way beyond the area of your interest, and then you can see if there are any interaction surrounding the area after the disaster occurred. So that is the two important things I would like to share with you when we consider using remote sensing. We want to know the locations. Number one, the location of the disaster and the extent of the damage. We can predict the impact zone whenever we have the satellite images. So the previous few slides just summarized some monitoring basis. I believe that every one of you can have a basic concept because that is the major purpose of a presentation today. Even though it is the basis of monitoring, but that is the core concept when we design our monitoring systems. And also it will help you to determine what kind of disaster management you want to do in your, when you need to make a decision. And the next part, we will move on to different subjects. We will focus on what is the wireless sensor network, WSN, and the IoT. Those are the techniques we can apply to obtain the data and put them back to our GIS platform, and you can combination with the remote sensing together. So we will move on to WSN and IoT for the next part. So for the WSN and IoT, we're starting with the questions. I will explain what is the WSN and what is IoT. And the next one is what they can do for our disaster management. The first one is WSN. Wow. Now, imagine you have a smartphone by your hand, and today we have different sensors installed in the buildings. You are sitting in your living room, for example, and you lay down on your couch. You just take out your cell phone. You will get temperature, your pressure, or the rainfall, precipitation, electricity, or even the humidity. You can collect all the data quite easy directly by your cell phone, because your cell phone just call the sensor to send information to you. And that is the traditional way we ask service. Then the sensor provides you the data. Now, today, we have evolved the traditional way into a new stage. We want the sensor can communicate with each other. For example, if one sensor senses the temperature is too high, he will turn on the air conditioner to cool down the indoor temperature. If the sensor senses the electricity has some irregular response, then he will send out the warnings to you, and then you need to take a look what's going on in your house. So we want the sensor to communicate with each other. Well, that is the sensors network. We try to connect them together. Now, today we have a better technology. We can put everything onto the cloud. Wow, it's not the real cloud. I mean, it's more like an internet. It's a cloud. We put everything on that, and then you can obtain your information. That is how it works today. We have the sensors. You can choose your own sensor in your house, and you can set up the rules, and then you will get the information whenever the rule is triggered. So you're living in a building, in an apartment, you have all these sensors, we put them all together on the cloud. And there will be a simple example. It's a very easy, a simple one application of a wireless sensor network, because each sensor either communicate with the other or not, but they all send out the message to you wirelessly. So WSN stands for Wireless Sensor Network. It's that by definition, we need a sensor. We need the sensor to communicate wirelessly. And then we need the communication to be set up as a network. So there are three major components. We need the sensors, we need a network, and then the capability of sending information wirelessly. And WSN contains three major parts, like I mentioned before: the sensor, communication, and you need to do some calculations. Well, this is a special one. For the wireless, for the WSN sensors, each sensor can do simple jobs. Meaning, we want our sensor to, I want our sensor automatically to respond for certain condition whenever the condition is triggered by the rules. And the rules is meaning the algorithms. So we can set up a lot of the sensors. Each sensor we call it a node on the WSN network, and each node can communicate with each other. So these are simple illustrations. We have a region we want to monitor or to sensing. Each node is a green circle on the screen. Each node represents a sensor. So these all sensor nodes, we can collect the information by setting up your algorithm. Then he will send out the monitoring result to our base stations. And he was, from the base station, after collecting all the data, he will kind of compact all the information together, send you to our users directly through the internet or directly to you wirelessly. So this is a wireless sensor network. It's quite simple to understand. The next one is the IoT. Well, IoT stands for the Internet of Things. Most of us have already be familiar with the terms IoT, but it is actually to appear in 1999, almost 20 years ago, more than 20 years ago. It tried to connect everything together because by definition, I think there is one definition I would like to share. The IoT just provide the unique identifiers, and each identifier can communicate with each other to transfer the data over a network. So again, here emphasizing the internet. I would say internet is another word of network. So it's a IoT is similar to your WSN. So we put everything onto a network, and here everything is a sensor. Each sensor can operate by itself based on the algorithm we set up. Then it will be a IoT. So we probably have thousands of WSN all over the world, and we put them all together. He will construct one big global IoT network. So that is the idea about the WSN and also the difference between the WSN and IoT. So for everything, the IoT is just designed for communicating with each other for everything. There are three categories. One is a traditional one. One sensor can collect information, then send the information out. Another one is we can receive the information and do something based on the information we received. And the last category is the sensor can do both. So of course, we want our sensor to be smart, and he can automatically operate certain things without our supervision. So I live in Taiwan. We can set up a one WSN here. Maybe someone living in the Southeast Asia, for the people living there, can set up their own wireless sensor network. And for those who live in Europe, you can have another WSN. We can put them all together. There will be the global internet. I would say it will be global IoT network. So this is a very easy and simple illustration of the WSN and IoT. So let me re-emphasize one more time. What's the difference? What's the importance of the WSN and IoT? They both contain sensors. So we rely on sensors, but only sensors is nothing. We need them to communicate with each other. And the next one, we need to set up a network. The purpose is try to collect information as much as possible, as better as possible. And also we want to find the difference as early as possible for our disaster management. So the application for disaster, well, here's the scenario. Today, right now is the Saturday morning. You just have a happy Friday night, and about 6:50 a.m. You hear the raining sound outside. So you probably know that, oh, it's raining, but you still lay down on your bed. But within 30 minutes, you notice something went wrong. There's water coming into your room. That is a flooding. There's the water coming to your first floor, and you find something serious happened, and you try to evacuate from your house, but only 30 minutes later, it is a scenario that you don't want to face. You want to know the situation. You want to be notified when the situation is getting worse. So here, let's rewrite the scenario, and we make some difference. 6:50 in the morning, you kind of wake up and you notice there's a raining outside. I think, oh, that's fine. It's normal in Taiwan. But at 6:55 in the morning, you got the warning message directly sent to your smartphones. It said there's a flood warning. Evacuate right now, because there's a heavy rainfalls, and the system predicted it will get some damage to the people living in this area. So leave your house right now, because there could be a flooding right in the next few minutes. And at 6:55, you saw the message and see, wow, there's a flood warning. You wake up and you wake up all your family and prepare yourself and try to find a safety place. You can leave your house, or you can just move to the upper stairs at a higher position to protect yourself. So that situation gives you the ideas. If we want to protect our people from the natural disasters, we not just only need to monitor the data. We need to do something after we obtain the data. So we can apply the WSN to the location. You can put a lot of sensors at a different location, try to help you to obtain the data from the rainfall, and also the depth of the flood, and also how close the sensor between each other. Then you can predict the flooding propagation. So this is just a few examples I have highlighted here. For WSN, you can apply them to the landslide detection. You can put the sensors on the ground surface of the slope. And also, again, of course, you can put them to capture the data for the natural disaster. So the natural disaster here, like the scenario I showed you before, is the floods. So we want to measure the rainfall, the depth of the water, and also the distance to the subject. And then you can protect yourself before the worst scenario actually occur. So about IoT, well, let's think in different angle. IoT is a bigger WSN. You can set up a lot of WSN at different locations, and then you connect them all together. I would say that will be a IoT network. So you can help you to do the disaster warning. Here, as a scientist, we usually want to help people to make an early warning for certain types of disaster. We want to set up a time window. Okay, so let's catch up. And for the IoT applications, and especially for disaster warnings, we want to make early detection because it is important to our people. As a scientist, we usually work hard, try to find out any prediction model that can help us to determine the time window for evacuation for certain natural disasters. So, for example, the flooding is a predictable disasters. Whenever we have the data of the rainfall and the depth of the flood and also the location of the flood, then we can using the GIS to try to predict the future flooding area. But for another example is earthquake. Currently we cannot predict the occurrence of the earthquake with today's technology. We're still working on that. We need still try to find out different methods to help us to predict the location. I'm sorry, not the location, the occurrence of the earthquake. Well, nevertheless, IoT with the WSN can help us to collect the data. And the most important concept is to find out the early detection. We need to can have an early warning as early as possible, such that we can set up a time window which is long enough for people to evacuate from the dangerous zones. Here is an example using the WSF for landslide. It's a real case and it's published on the paper. We have a different sensors. We just installed a sensor on the surface of the rock slope. And we have a different sensor. It's a simple sensor, which is the tilting sensors, and also has the acceleration sensors. So whenever there's something is moving on the rock slope's surface, he will trigger the signal, and then the system will obtain the signal. Now, here's the false alarm question next. Is it really a moving rock coming down, or is it just a false alarm? So you need to set up the algorithm. Remember that in the previous slide, you can set up a simple algorithm in each sensors. So if there's one sensor sending out a signal, it will compare the signal with the sensors surrounding itself. If only one sensor sending out a signal, but the others has no signal on it, others saying, no, I'm fine. Just only one person saying, no, it's not good. Then the algorithm will identify that is a false alarm. I think it's quite easy to do the job on site directly. So we don't even need to ask a person to make a judgment. Sensors can do the work by themselves. Another example is in Taiwan. This is a project I
I handled years ago. We tried to monitor a slope, and there's a people living at the village at the town of the slope, and we need to monitor 1, 2, 3, 4, 4 potential landslide regions. So we set up the sensors. So all this is simple. Just provide us a simple concept of the WSN. I would say, IoT as well as the WSN, we put them all together. You can move, we can upload all the information on the cloud. We say cloud computing is quite popular right now and is very useful today. So the users or anyone who is interested about the disaster or anyone who is care about the living areas, they can obtain the information they want. So I think it is the future. I'm sorry, not the future. I think it's ongoing inspection or the future goal of our of our disaster management. People can do something by themselves. You need to teach your people to learn something by identifying the information, and then he can protect themselves, not just only rely on the government to provide them the information. So I will encourage everyone to understand the monitoring basis and also understand what types of the disaster that could make you most concerned in your living area. And then you need to put attention on that, not just rely on someone to tell you to go or to tell you to evacuate. You need to rely on yourself. I think that is important issue today. That's also my point. That I want everyone can, for certain level, understanding the disaster threats, also understanding the information about monitoring disaster. So in summary, we have the sensors. We can put them together to construct a network, and then you put a lot of network together. It will be Internet of Things. So the value of the IoT is the auto doing upon the requests. So that's why some scientists try to study the algorithm that of the response. That should be easy to run, and also it should be a short coding that we can put them on each sensors. So right now we finished talking about the WSN and the IoT, and also we introduce you about the monitoring basis. We have the concepts of the simple questions, and also we have the insights of the disaster management. So far, so good, I suppose. So the next part, we will move on to three examples of the natural disaster in Taiwan. I will use the landslide monitoring as one example. The next one will be the debris flow monitoring. And the last one will be urban flooding monitoring. So give me 10 seconds. I will get a sip of coffee. So let's move on to the landslide monitoring. So we already talked about the technology using the GIS and the remote sensing. We also talk about the network concept. You can use the WSN or you can use the IoT. Now the hard part is we need to put them all together. You are the users. Sometimes you will for some time you probably are responsible for disaster management. So the hard part is how we do the management correctly and promptly. So for landslides, I will repeat the same question in the next two different disasters. For landslide, we usually ask, what are the causes of the landslide? So you need to know what is the key issues. What are the most concern you have? about the landslide. So for your concern, how we overcome those concerns to help us to be safe during a landslide. So we need to monitor something. And how we monitor a landslide, what kind of options we have, and also, and the final one, I will give you a case I used to work with. And in Taiwan, we try to monitor a landslide area around a village in the northern Taiwan. So landslide monitoring, well, let's repeat one more time. Remote sensing can help us obtain wide, larger area, obtain the information about wider, larger areas. It is categorized as the no physical contact options because he rely on the aircraft or just a satellite image. No physical contact on the ground surface. Another investigation we call it on-site investigations. So for landslide monitoring, you either choose the remote sensing to help you to obtain the local condition image, or you send someone, experts, to go on the site, and you need to do some investigation, rely on the different sensors, or rely on your eyes, your own professional knowledge. And the on-site investigation here is categorized as a physical contact because actually someone go on the site. So this is the two major difference between the remote sensing you can use for your landslide monitoring, but also you need to consider you send someone or send a team to help you to investigate the local conditions. That will regards to the how detailed of the information you want and the scale of the monitoring you want to do in the next step. So let's take an example. This is just a satellite image. You can take the image something like this, and you can emphasize the elevation with a different color. And we can notice that the satellite image, especially with the radar or the laser line, will give you very precise the elevation of the mountain areas and the hill areas and also the village regions. And you can do your analysis based on this map. This is the one example you can use in the remote sensing. And for on-site, on the other hand, on-site investigation, we can put the sensors on the site. So this slide shows you can put different sensors right here on the site. So you can narrow down to the locations you are interested in. And you can we can put them especially for debris flow, for sediment transportation, or for the local ecosystems, or for landslide right here, and also for the bridge damage. So you can narrow down to specific subject of the monitoring. And then you can, with the communication methods, you can obtain the information from the site back to our emergency operations center or directly back to your cell phones. That's quite easy to obtain the data. But we need a person to install the sensors or instrument on the site. So what are the key issues about the landslide monitoring? The number one, locations. Again, locations usually the number one and the most important issues of the disaster. Where are the landslides? Or in other words, where are the potential landslides? So we need to identify the location of the landslides. So most likely locations, and also whenever there's a landslide already on the site, what are the affected objects or what are the people that will be affected by the landslide. The next one, we need to determine how serious a landslide could be, the range, and also the area. So we're concerned about the most is the impact zone. Oh, and then today we worry about more about the chain reaction. For example, if you have a landslide close to a nuclear power plant, that will be a very serious problem. If a landslide actually occurs, what is the chain reaction if he damaged our nuclear power plant? There's the radiation. There will be a radiation damage to far away from the location of the landslide, and then that situation is the serious one we need to take into consideration. The next third question is the volume. I mean, how much a landslide could generate. Well, this is a tough question because today I believe we don't have a good method or sensors can directly measure the volume of a landslide. We can, using a satellite image, somewhat to guess the depth of the landslide. Then we can evaluate the volume of a landslide by certain assumptions. That is what we can do now. But why this question is so important? Because the volumes, if you have, I would say, if you have 10,000 cubic meters, 10,000 cubic meter Earth of a landslide, he kind of slides down, so he need to fill up certain area, right? And then where it goes, he probably will bury the whole village. He probably will bury few houses, or he probably just bury a creek, a smaller creek. And that is the question regarding the volume. We want to estimate the volume of the landslide. Sometimes we worry about how it will be in the future. And then we need to, for that questions, and then we need to prepare ourselves. Whenever it occurs, we need to find something to help us to clean up the landslide debris. So talking about the on-site investigation, we already know you can use the different sensors, and with the communication, we can send out the information back to our operation sensors. So let's see what WSN can do for you. This is one example from the paper, published journal paper. He tried to monitor the movement of a soil mass on a slope. So this is very easy, and this is a simple trial. We just put an accelerometer on the surface of the soil. And if the sensor sending out the message, sending out the signals, when the soil mass is moving, your computer will receive the notifications. It's very easy for the landslide monitoring. However, there's some shortcomings of the sensors. I'm sorry, for these systems. What if the sensor is buried by the soil? Then you will lose your signal. So that is one question we need to consider. Another example is from another paper. He actually put on the accelerometer on the surface of the landslide, and he monitored for a longer time. And luckily, he observed one movement, one obvious movement of the landslide surface. So he identified a signal in a different stage. There's the one stage we call it the motion stage, meaning the landslide, there's something actually moving on the slope. So this is quite useful and a very good example for landslide monitoring. If you can identify the signal stage, telling you the soil mass is moving, and then you can send out the notification, the warning to the people living at the down slope to ask them pay attention or even ask them to evacuate. This is a good example for the landslide monitoring. Another one is for the rock. If you have the rock slope, we can simply put the sensors on the surface of the rocks, because whenever the rock is moving, they will send out a signal. And from the proposal of this paper, the authors also used the satellite to receive the GPS. He also used the GPS receiver on the ground surface to identify the location of each control point. So whenever there's something change, when something happened and the ground surface will have the change, will have the deformation, it will trigger the signal, and then we will obtain the information from the site about the difference. So this is another example of the landslide monitoring. And there is a professor, he developed all-in-one sensors try to monitor the soil landslide. So he just installed the sensors all together in one tube and put them in underground. And at the top of the tube, he just set up a transmission. He will send out the data from the location to the receivers. So this is quite easy to understand. It's a very simple design, but it's useful. This is useful for small scale monitoring. You can set up a few sensors tubes at a different location to obtain the information of the site. And this is the example I just showed you in the previous slide. We try to monitor the rock slope. So in summary, this table gives us the idea when we're talking about the landslide deformation monitoring, what kind of sensors you can use. You can use the acceleration transducer, displacement transducer, and also the angle sensors. And for different types of the landslide, which sensor is useful, which sensor is probably not so good, I just summarized in this table, give you the idea. And we can set up each sensor all together to construct, we call it WSN. Okay, so even though the WSN is very convenient for our monitoring, but we also have some difficulties today. The first one, remember that we try to cover an area, then we need a lot of sensors. Widespreading sensors. The number one issue is how much it will cost. And the next one is there any commercial product already on the market, or we need to develop our own sensors? They all requires the money and the time. The next issue is installation. Sometimes it is difficult for a person to climb up to the rock slope, to the top of the rock slope to install the sensors. So there is another issue regarding the safety of the installation. So we need to pay attention on that. We need to find out a safe way to install our sensors on the site. The third one is the communication. Communication usually is the most important one. If we cannot communicate with our sensors, then the sensors is useless because we don't have any data coming back from the site. And the next one is the power. Each sensor operates by the power. You can either put in the batteries or you can use the electricity wire connected to our sensors. Either way, but our power has time to spend up. Sometimes we will running out of the power. How we ensure the sensor can survive as long as much or as long as we want. That is another issues about the WSN applications. So now move on to the IoT. Well, like I said, like I mentioned before, IoT is another bigger scale of the WSN. You can put different sensors at different locations. So you can monitor 2 or even more landslide areas together all the same time. All you need to do just try to set up the separate WSN networks for each landslide locations. And then you need one IoT network to connect them all together. So this is an example I worked with a few years ago. We tried to monitor in the landslide area for a village at northern Taiwan. And here is the geology and also the terrain map of the this village. We have two potential debris flow torrents here. But we worry about is we have different potential landslide areas. We have 3 major landslide zones, A, B, and C. So for different zones, we have different considerations, and we set up different sensors on each landslide zones. This is the on-site photos. We take aerial photos from the UAV. We can not identify directly by our eyes. There could be a potential landslide areas. This is another view of the zone B. And we also have the information about the water. We want to know the groundwater table, underground water table, because it will affect the safety of the landslide. This information, we put them all together onto one GIS platform. So this is the profiles of the testing lines. We put them all together on one GIS platform. So GIS is actually useful from this example. Put them all together, and I can determine the location of the sensors. Because we want to monitor in the water, so we need the water pressure installed at certain locations. Second one, we want to measure how much rain, like how much is the precipitation. So we need a rain gauge. So we set up the rain gauge at different locations, and also we need a data logger to collect all the data. So we have a different smaller WSM for CCD, for your for our water pressures, and also we have a wider, larger WSM for base station. We collect the different types of sensors together. And here is an example, the photos of the site. So we set up the water pressure for 4 water pressure, 1, 2, 3, 4, at the different locations, and we all connect them all together. And final one, this slide shows you the management purpose. If you are the director of the village, or if you are the chairman of the village, you probably need this platform. We call it the management dashboard. We highlight the information on one platform, one screen. You can have your location informations. You can have your monitoring data at a real-time manner. And also we provide, we set up the algorithm of the disaster response. So we have alerts and warning lights. If it turns from green to yellow or from green to red, meaning there's something happened on the site, the chairman need to pay attention to that. If that is a real issue, there's something really occur on the site, we need to announce the evacuation to the people of the village. So we call it the management dashboard. This is our final product we want to show for our people. And to do this, we need we need to set up the sensors. We need to set up the network. We need to set up the communication, and we need to set up the algorithm to help us make decisions. Put them all together, you will get a very fine dashboard like this example to help the people understand the threats of the disaster. So in summary, we can apply the WSM for on-site data and pre-processing on the site. And we connect all the WSM as an IoT. And in the future, there is an example on the slides. This is the future of the WSN. I believe if the sensor can plug and play, meaning if you have a base sensors and you can plug in different function sensors all together in one box, like the photos I show you, and then it will a very powerful WSN sensors because you can do different functions together in one sensors. And the algorithm can communicate with each other. He can do different things, moreover than ever. So that is the summary about the WSN and IoT application for our landslides. Then we move to another example we call debris flow. So similar to landslide, we need to answer the questions. What are the major causes of the debris flow? So we need to find out the major cause. Then we can set up our monitoring options. Then we can set up our management systems. This video shows you the real-time video clips we captured for debris flow occur in the middle part of the Taiwan. It's quite shocking when you first time watch the videos. You can search the video on the internet because it occurred captured on the 2009 after the Typhoon Morak. So debris flow is a common disaster in Taiwan, especially for mountain areas. So as early as 2004, we have a debris flow. He carried out a lot of sediment or debris, soil, rocks, moss, etc., all together and buried the village at the downslope. Then here is the most recent videos captured by the TV news reporter. It is a village occurred in 2015 after the typhoon Solar in August. So as you can see, the debris flow flowing down. There's a few houses just by the riverbed. But luckily, in this case, no one has been damaged. I mean, everyone evacuated earlier and before the occurrence of the debris flow. So what is the debris flow? There's a lot of too many words. I won't read it. And in simple one, debris flow is a facing moving landslide with a smaller scale. And he will carry out large items, soils, trees, boulders, and even a car. And in the previous slides, the video shows you they even moving out a house. Okay, so he is a rapid disaster. It occurred in a very short time period, and then he will cause a serious damage to the people and to our properties. So what are the major causes of the debris flow? We need a lot of water. We need a debris source. And then we need an adequate slope such that the flow can flowing down from the upstream to the downstream. And usually the triggering factor is the intensive rainfall. So what are our concerns? We care about our people's life. We care about our properties. We care about our public facilities. So now we understand the major cause of the debris flow. Then we need to want to measure the rainfall, the flow speed, and flow the height, or the ground surface vibration. And then we can determine our sensors. We can use the rain gauge to measure the rainfall. We can use his speed meter to measure the flow speed, and we can use some other sensor to help us identify the occurrence of a debris flow. The next one is we need to set up the communication options, and we need to obtain all the data needed for our later management and decision. So we need to do the measurement on site. We need to set up the sensors and set work, and then we need to respond to the disaster whenever we have the information. So this is just a table of the sensor we use in this case. And there's a one I highlight here. We call the contact type. The geophone sensors and the wire sensors can tell you it is a debris flow coming through, and it is real. It's a different to the rain gauge. Rain gauge gives you the rainfall, but it's the rainfall number cannot guarantee a debris flow is actually coming or not. But the geophone and the wire sensor can actually tell you a debris flow is actually coming. So we also have some other options for monitoring the debris flow, which is similar to the landslide monitoring. So what we do for the monitoring debris flow, so this is our goals. We want to collect data. We need to, the data coming back from the site to our emergency operation center, and then we need to make decisions. So we rely on the sensors. We rely on reliable communication network. Today, we rely on our cell phone network, but sometimes we rely on our satellite images, and satellite communications. And also we want our sensor to monitor the data 24 hours, 7 days, nonstop. So then we need to design our batteries or power provider. So this is a figure we use for debris flow monitoring on the site. And currently in over the Taiwan, we have more than 20 on-site monitoring stations, and we have more than 100 rain gauge installed on the mountain areas all over Taiwan at the locations of potential debris flows. So this is quite a simple manage and monitoring system design. So the system must include the sensors, communications, and power supply. This is the three most important components of a monitoring system. But not only just for the data we collected from the site, we need to make decisions. So management, we need to design our criteria. For certain conditions, we need to respond to our disasters, and we rely on our criteria to do the job. So the debris flow monitoring, I introduced to you the basic monitoring sensors and basic monitoring systems. Now we'll talk about advanced monitoring. Well, I just take the debris flow as an example. So you can apply similar concept to different disasters. The first one I want to share with you is the mobile monitoring. What does the mobile monitoring mean? Here is the real debris flow videos captured on the site. Let me show you. And the figure on your left hand is a signal from the geophone. As you can see from the CCD camera, there is a debris flow coming to you close to the sensor, and the signal will change. As you can see, they have a different signals change. We have a peak values, and whenever the debris flow pass away, and the signal will go back to normal. So this is the case. This is the case we capture the debris flow in real time. And we want to capture the debris flow as early as possible. So today, debris flow comes from the upper slope. You live at the down slope. We want early warning. So we want to set up, we want to create a time window long enough for people to evacuate. So how we do that? We want to monitor the debris flow as early as possible. So that is our purpose. So we want the people to be aware of the debris flow as early as possible, and we can make a decision as early as possible, and we can do something as early as possible. So we need to censor, reliable communication, all the same. All these components are the same when we discussed about the WSN and IoT in our previous slides. But the final one, the mobile and stable. we want to set up our sensors at the upper stream, even at a very remote distance to our village, because we want to capture the debris flow. The earlier, the better. So if we can have our sensor to monitor the difference or the change at the source of the debris flow, and then we can create a longer time window for evacuation. So that's why we want to put on our sensors at the upper stream. So we call it a mobile options. So okay, we can drive the car. You can drive the car with the sensors to the locations, or even you can ask someone to carry on the portable unit to even further, even remote area at a mountain area. Then we transmit the data wirelessly. You can transmit the data to the satellite. You can transmit the data to your cell phone, for example. This is a simple concept and a simple WSN application for debris flow at mountain area. And we call it a best-in-wide monitoring. So we can put all these sensors together. Some sensors we put the upper stream, some we put it at the middle stream sections. Some sensors we put at downstream sensors. We want to communicate. We want the data communication wirelessly. So we put all them together. So how about we drive a car? We just carry on all these necessary sensors to the even remote areas, and using the satellite communication, and we have our own generators. So that's why we design our own mobile monitoring. Truck is it's not a good word to describe. I would say it's a mobile monitoring stations. So we set up, we remodel a truck, and then we put our sensors on one truck, and it will more like a, I would say, if you ever watch the movie Transformers, we want our car can transform to a type that we just need to leave our sensors on site, and the people can drive the car back to the safe place. So how about we design the sensors together and the car on the other part, and we put them together. They can separate with each other. So that is the newly designed monitoring mobile stations. So you can drive the car on the site, and then you can just leave the monitoring box, I would say the monitoring instruments altogether on the site by itself. You just need to turn on the power. We have a power generator inside the box. You can survive on the site by itself at least 3 days. And the people just drive the car back to the safe place. So this is the idea of the mobile options. So we have different types of mobile options. And that is a concept we can apply similar concept to different disasters. The next question is, can we do more? Because sometimes you can drive to the car, but whenever the traffic is broken or there is no traffic you can access through, then we rely on the manpower. So we need someone, a person, to carry on the monitoring sensors to the remote area. We call it portable sensors. So these are the sensors we need. We need a rain gauge, geophones, and soil moisture, and we need a power unit, and also we need communication options. We put them all in one box. This is not the general box. We want the box is the weather resistance in a compact size, and it's durable. So this is the final design of the portable units. We have the batteries, we have the sensors, we have the transmitter, and we even have not a PC, a computer, a small, very small computer chips inside the sensors. So we can do all the functions automatically. When you turn on the power, it will operate by itself. So it's easy to carry. It will be the design, and the final version will be something like this. We have 3 different types. We have the basic types, advanced, and the premium types. The difference is, if you try to have a 60 camera to capture the on-site image, you need to carry on the 60 cameras. But usually we only need the rain gauge and the geophone on the side. So we have a lightweight model instead of the basic model. It's even smaller, lighter, and it's easy to carry on. And we put them all together in one microcomputer, and you have the chips and functions we set up, and he will do the jobs by itself. So this is the operations actually case. So I already introduced the on-site monitoring, mobile monitoring, portable monitoring options. We just put them at the mountain areas. And then we can set up a relay station. We can transmit the data from even remote area. So you can transmit the data for longer distance by the relay station to transmit the data through the through the cell phone network. So these are 2 examples we set up on the site. So you can set up a monitoring stations that are very far away from the village, and or you can set up the smaller, compact sensors at location not easy to access. Here's another case in real time operation. It's in 2011 we have the typhoon Namadu, and whenever we receive the typhoon warnings, we send out our sensors. We put them at the upper stream and the middle stream, and we turn on the power and leave it. It will start to capture the rain gauge, the moisture sensors, and also the geophone signals automatically. And we will put them all together on one platform. We call it a dashboard. It's a management dashboard. We represent information all together. Another case is whenever we on call, there's some emergent case, we can just ask a person to carry on one portable unit on the site and turn it on and leave it. And we will start to collect the data like we did for the typhoon events. So in summary, whenever we design a monitoring system, we usually think about on-site monitoring. We install sensors on the site, but we can also consider how about we create a movable monitoring network. So the sensors can be put on the location whenever we need it. So we call it a mobile monitoring network. So we can combine the on-site monitoring network with mobile monitoring network together. Combine them all together, you will fit different needs when you need to face the different disasters. So this is a concept I show you from the presentation that we consider, we need the sensors, of course, but we can use the sensor in different ways. So the different ways is meaning we can create different network type. So you can put an on-site network. Also, you can create a mobile monitoring network. So I will show you the final case. We have in the Vietnam. We have a debris flow. And in the Vietnam, we call it Sapa. It's the northern part of the Vietnam. And this is the location. This is the satellite image I captured from the Google Earth. So this is the location we need to monitor. It's upstream and it's a downstream. And we set our monitoring location at the downstream. So for upstream, we have the sensors to capture the rain gauge to measure the rain gauge and to measure the rainfalls to capture the signals of the geophones. In the downstream also have the rain gauge and the geophones. And we set up the CCD camera at the downstream locations. We send out all the data will be collected and transmitted back to our base station and downstream. So this is the operation systems. Again, it's a similar questions. Why we do the debris flow monitoring at SOPA, and what to monitoring at the SOPA, and how we do the monitoring. It's a similar question one more time. So ask yourself why and what and how when we think about our monitoring system and management system. So for upstream and downstream, we have different types of sensors, and we have one monitoring system. So we collect all the data together, put them in our base stations, and we can transmit data in real time. So for example, in 2020, there was a tropical storm. They approaching the northern part of the Vietnam. We can see the data directly from your cell phone because we have a wireless network. So you can watch and get the information from your cell phone, and you can make a decision if this is a serious case or not. Also, you can switch your cell phone to watch the on-site CCD camera. You can watch the real-time image from the site. So sometimes when we try to announce a warning notice, sometimes you want to check on site if this is true or is it a false alarm. So CCD camera somewhat will help you make the decisions. So if that is good enough for our monitoring, well, there's always a point to be improved. The first one, accountable. If we rely on rainfall to announce warnings, usually we have a false alarm. So we want to change. We want to improve that. So then we need to rely on different sensors. Different to the rain gauge, we rely on our ground surface vibration. So it's a geophone. Like I said before, if there is a debris flow coming through towarding to our sensors, there is a signal change, very obvious signal change. They will pick values from the geophone signals. So there could be a good tool to help us capture the occurrence of debris flow. So, and we want them to do that automatically, because whenever you detect any signal, irregular signal, and you will announce the warnings to the people. So what we do, and the first one, the why rainfall matters, because it's easy to measure. I think it is a major reason. You can install the rain gauge at any location you want. And how? But we want to avoid false alarm. So we need to consider another data from geophone. And here is the locations. Here is the case. So we have a major a debris flow here. Is a video coming through. And we have a wire sensor broken, meaning the debris flow passing through the location of the wire sensors. How about the geophone? And then we notice that there's a peak values right here for different at different location. We noticed that the signal peaks occur whenever the debris flow passing through the sensors. So this is a feature, a characteristic. This is a characteristic feature we can use for prediction and the detection of the debris flow. So we notice that when we convert the signal into energy, it's quite obvious. We notice there's a jump in our figures, and these jumps will imply that occurrence of the debris flow. So Combine them all together, we want to set up early warning models. We need to set up different criteria. The first step is rainfall threshold. And the next one will tell you if this is a false alarm or not. We rely on geophone signal. And then we need to make decisions. And then we need to check if it's actually a debris flow or not. And if it is, then we need to ask our people to evacuate and protect themselves. And then we can upgrade all everything I mentioned here to the IoT scale. So we need our sensor. How about let our sensors talk with each other? How about ask our sensor to they can communicate with each other and they can do something automatically. He can make their own decisions by our criteria. So we don't need to wait. We don't need to wait the data collected from the site to our emergency operations center. The sensors can do something at first. He can announce the warnings to the people living at the upstream area, and they can evacuate without the government notice. So that is the concept to upgrade to IoT network, to do the things with each other, communicate with each other, and the most important, make a decision with each other based our criteria. So in summary, the debris flow digester is just one example I would like to share with you. In these examples, we discuss about the monitoring system. So not just the sensors, not just the network. You want to consider, you need to make a decision when you manage. You need to make a decision whenever something wrong occurs on the site. So we need the criteria. You need the reliable information. And to get the reliable information, you can apply IoT, you can apply WSA, you can apply smaller scale monitoring, larger scale monitoring. You can use the GIS, you can use the remote sensing techniques. The final example I would like to share with you is the urban flooding. I believe the urban flooding, like this photo shows you, is quite frequent to occur in recent days. We call it a flash flood. Usually within few hours, a lot of the water coming down to one area, and then it will and then the floods will affect your life. And even serious, it will be a larger area whenever there's a intensive rainfall for days. So that is why the urban flooding is an issue today, because it usually cause they probably not cause serious casualties, but it will cause serious damage to our facilities, because during the flooding period, you cannot you do nothing about that. You cannot accelerate the flow out of the flooding. You have to wait. You have to wait the flooding disappear with the time. So that is why today whenever we sense something about the flooding to occur, we need to know the situation as early as possible. So again, we repeat the same questions. Why we need to do the flood monitoring? We need our people to be prepared. We need to monitor how much water from the rainfalls. And also we need to do our decision. There's one difference here. For preparedness, we cannot construct a real flood in our real world, because there's no location can do that. Even in your laboratory, the scale is different. So here we talk about how we be prepared for the flooding conditions. We use the simulations. So the simulation is very important here. For simulation, if you want your simulation result is reliable, you need to collect the data from the local area and for a longer period. You need to try to collect the correct conditions of the location such that you can construct a reliable simulation conditions. So we need the sensors, we need the reliable communication, we need a real-time response. This is just similar to the previous slides. So for scenario here, it shows your video here in Taiwan, in the middle part of the Taiwan. Where are the hotspots of the flooding, of the urban flood? Well, you can make the analysis based on the case studies, or you can just run the simulation like I show you here in this video. And we can see that for each hotspot, we can predict how deep the flood could be. And then we can make zones for the hotspot zones, and we can set up our labels of emergency based on the depths of the floods. So the first step, simulation, is quite important. When we know the location of hotspots, and then we can set up our sensors network at hotspots, and then we can create our network. Today, we can rely on our people. Everyone have a smartphones. You can ask everyone that who is living in the area using the smartphone to monitor the flood. It is doable and it's possible today. And then we can make our own decisions. So let's take an example here. We want to measure the rainfall, and then we have, based on our simulation, we can predict how deep or how serious the flood could be in the next few hours. That will be our early warning. We can create a time window for evacuation. And we hope that we can do that automatically. The system do the job for you. So we put the sensors. This is our prototype of the sensors to try to measure the water depth, the flood depths, and we want to measure automatically. So we use several techniques we use today. You can image processing, and you will use in the image detection. Today we can even use in the AI algorithm because they can recognize easily with the depths by the AI algorithm today. And we put them all together and in one sensor box, and we install them at the hotspots of the flooding. So these here are the location we put our sensors on site. This is a real case and it is working now. So how about the next step? Can we put more sensors? Of course, we can put more sensors, but we need to cost a lot of money when we put the more sensors on the site. So how about we ask the people to help us? So we call it a volunteer report. And it's a crowdsourcing. I would say it's a crowd sensors. So we just need to provide them an easy application. You can put them in your iOS smartphone or Android smartphones. You can open the app, take the photos using the recognition, or you can tell us how deep it would be, or you can just send the photos back to our system. The system can recognize the depth of the water. The depth of the water by the system automatically, and you just need to upload the data. Easy to do and very convenient for everyone. But I would say this is only for flooding disaster, because flooding is kind of a progress slowly. Sometimes quicker, but it is a progress that you can see. So for the criteria, we have the rainfall, we have flooding depth. Then in combination with our scenario simulations, we can make our decisions. We can ask people to evacuate when the flooding propagate to a certain locations. So here is the examples. We have a simulation for 450 millimeter flooding depths. And we also have fragility maps for the people living around here. And then we have different scenario of the evacuation route. There's one route, there's one way to evacuate the people, but it's not safe. So for simulation, we can make our decision previously before the actual flooding occurred. And then we can provide different options for our people living at these areas. You can go to the location A because it's close to you and the pathway is safe. Some people, you need to go to the location B because it's close to you and safe. So either way, it will help you to make your decision when in response to the urban flooding. So we need, and this is the important one, we need to do the safety check. That is why we need to run the simulation. And to run the simulation, like I said before, we want is a correct simulations. And we rely on accountable data, monitoring data from the site. So in summary, urban flooding is a serious issue today. I think it will be the issue in the future because we have extreme weather now, and the climate change actually caused the difference today. Actually caused the difference when we compare 20 years ago. So we need to pay attention on we call it the rapid disaster. Urban flooding is one of the rapid disaster today. And we can use our WSN or IoT, all in one word. We need a reliable monitoring network. So people can be a sensor today. We all have a cell smartphone by hand. You can do something to help us, to help yourself under when we in response to the disaster. So simulation also and simulations and the forecasting are important for urban flooding monitoring. They are also important for other natural disasters. So this is pretty much about the cases we talk about today. We talk about the landslide monitoring. We talk about the debris flow monitoring. And also we talk about the urban flooding monitoring. These three natural disasters use as cases to illustrate the concept of the WSN, the IoT, and the techniques of the GIS and remote sensing. Different techniques play different roles, and combining them together by ourselves in a smart way will help us on the disaster management. So thank you very much for your time. I think in conclusion, this is a coffee cup.
Sorry for that.
Well, that's okay. So like the conclusion, I already mentioned all the content before. You can use the GIS, the remote sensing as the techniques today. WSN and IoT is another concept we're talking about the monitoring network. And usually ask yourself the three simple questions: why we monitor, what to monitor, how we monitor, and what we need to do in the next step. And combination for different levels of monitoring needs provide better coverage of disaster. And as I mentioned, I want to emphasize at the very end, simulation forecasting is really important, but we need to rely on accountable monitoring data. Well, this is the reference I use for the paper, and you can check out online. And thank you very much for the time. And it's a pleasure time for this afternoon, about 2 hours, sharing with you about the experience of the disaster monitoring. and disaster monitoring and disaster management. Thank you.
Okay, thank you, Professor Huang, for your insightful presentation. So due to the time constraint, we will now open the floor for maybe 1 to 2 questions. So we now welcome everyone to turn on your microphone or type your question in the chat box. Any question from the audience?
Do you have any questions or comments? They'll be fine.
Here I see one question from Sky Huang. He say, are those IoT or WSN servers are edge computing nodes?
I'm sorry, from Skyward. Let me check. Are those? Well, you can use them as the edge computing nodes. Yes, you can do that because WSN or IoT is a network. In my point of view, it's just a network. Each sensor is an edge. I'm sorry, each sensor is a node. So if you want to design the edge computing, it is possible. It is possible. Okay.
Okay, so any other question? Oh, here 2 questions. I'm really curious about how to monitor the earthquake.
How to monitor the earthquake? Well, that's a very good question. It's not easy to monitor. Well, it is easy to monitor the earthquake. You just need to install the, I will say, the seismology. There's a sensors that will detect the vibration generated by the earthquakes. Monitor the earthquake is okay, but we can only monitor the earthquake when it occurs. We cannot monitor the earthquake before the earthquake occurs because currently scientists cannot predict the occurrence of earthquakes. Okay, so we still have a lot of work to do. I have a question from
Chou.
Can we have firms that actually manufacturing some of the listed sensors? Yes. But there's some of the sensors is a commercial products. You can find them similar products on the market. And for practical application, the use cases. Yes, you can find the sensors. Commercial products, no problem. And then another question is, and how to integrate that to GIS in more sense? Well, simply put, GIS is a platform to collect data. Remote sensing is a technique to collect data. So we can collect data by GIS platform, and you can collect data by using the remote sensing. This is just one way to do that. And for WSN and for IoT concept, for remote sensing from the satellite, each satellite is a sensor. So we have hundreds of satellites orbiting outside the Earth space. Themselves, they will create a WSN, or I would say the IoT, by the satellite themselves. So the integrate here, I believe you are meaning how do we put them all together and collect the data all together. And this is doable. You just put them on the same platform. It can provide you different scale of the information. Or integrating the monitor. Well, like I mentioned, the earthquake is not easy to predict. So, but to monitor, you just need to put the location of your sensors onto your GIS. And for remote sensing, for earthquake, we want to find out the locations of the earthquakes in the previous years. the case study. And then for remote sensing, for those locations, we need to monitor the change, the ground deformation or any change on the ground surface, because sometimes he will tell us that something happened underground, and that could be the source of the next earthquake. So for remote sensing, we usually take the image of the location of the earthquakes in the previous years. And for GIS, we just collect all the information on one platform for case studies. Does that answer your questions? I hope so. Well, if you have any further questions, well, I leave my email. You can contact me with email on the slide. I show you on the slides, and I welcome you to ask any question or get any comments.
Okay, so it's about time. So let's thank Professor Huang again.
And well, thank you so much. It's my pleasure.
Okay, just for the kindly reminder, you will need to fill the Google form and the quiz as a proof for the of the attendance. So thank you, Professor Huang. Thank you.
Well, thank you, Dr. Xu, and thank you, everyone. Have a good day.
Please fill in the Google form and the 2-question quiz. If you still have questions, you can leave it in the Google form or email it to me. I will pass your questions to Professor Huang. Thank you very much for your participation. See you next week.
Thank you. Thank you. Bye-bye.
Thank you. Thank you very much, Professor Huang, for your teaching and for Dr. Xu for hosting. Thank you very much. Bye-bye.
Thank you so much. Have a good day.
Have a good day.
You too.